Cool. Can you see my screen?
No, I cannot.
To quit Zoom, so now I do it now. Oh my God, I should have done this a while ago.
That's fine.
Okay, that's okay. Yeah, I'm not gonna share my screen though. So welcome everyone to the 2020 APEC Groundbreakers virtual tour by APEC OUC. And this year our event would be the biggest one ever done with 174 sessions, including normal sessions, workshops, and hands-on labs from 123 different speakers over 11 days. Also, it would cover sessions on 4 different languages, and please remember to register to as many sessions as you can. And all sessions would be available to replay as many times you want for 2 weeks after the initial session date and time. You can also interact with the speaker at any time during the 2 weeks by posting questions or comments directly in the playback session page. And of course, I would like to say thanks to all our Oracle user groups and Java user groups that made this event possible, and also to our sponsors, Oracle Groundbreakers and CloudDB. Now for today's session, using OCI Streams and Oracle Streams Analytics to make sense of IoLT, or Internet of Things, data by Luc Bors. Please feel free to write questions at any time during the session at the Q&A tab of the Zoom webinar, and the speaker would be answering them at the end of the session. If any issues during the presentation, please feel free to contact me at any time on the chat tab of the Zoom webinar. Now, without any more delays, I would like to leave you with this amazing session by Luc. Take it away, Luc.
Hey, if all is fine, you can now see my screen. Welcome to my session. Use OCI Streams and Oracle Stream Analytics to make sense of IoLT data. And that L stands for living, so Internet of Living Things. Let's first have a short introduction of myself. Okay, my name is Luc Bors. I work for eProceed. We are an Oracle partner with a headquarters in Luxembourg, but we have local offices all over the world. We provide support services and consultancy services, and we have our own products and solutions that we sell to our customers. Currently, I'm head of innovation at eProceed. Also a partner and technical director, and for the Oracle community, I'm Oracle Ace Director and Groundbreaker Ambassador. I authored several books. The first one is about 5 years ago about Oracle's mobile application framework, and just recently this year I published one with 2 of my colleagues on Oracle Digital Assistant, which is Oracle's enterprise-grade chatbot platform. So let's see about today's session. I have a short agenda for the session. I will introduce the use case that this entire presentation was built on. I explain the individual components that were part of the solution. And then I will tell you how you can bring all these individual components together into one solution. And depending on the time, I either do a live demo, or I will show you a recorded demo. The recorded demo is the exact same, but it requires a little bit less switching between screens and desktops. So if time permits, I do it live. If time does not permit, I will do it as a recording. So there was about 7-8 months ago, we got a question from one of our prospects, and they asked us, can you help us to innovate with IoT to improve our production process? Simple answer is yes. Complicated answer is, okay, what do you understand? How do you define innovation? What is your production process? How can we improve it? in general, but all these answers summarized on one slide brings us to the possible innovations that we can share and implement for the customer. So possible innovations, sales office, all the information that needs to be available. You can do that by means of IoT, by sending out updates about stock quantity, determine the price for customers, and notify customers whenever the product is ready to be sold. So sales office, product quality, based on monitoring of the microenvironment, we could predict long-term quality. And also you can share information about stock in general, quality of the stock, demand of stock, anything. And then obviously supply chain. You can share all the information that is needed for the supply chain at every moment in time. So you can use Internet of Things, again, to warn about the conditions and quality when the product is en route from the customer to their clients. So you can check heat, you can check moisture, you can check light, and this all actually is a generic IoT solution. You can use sensors to monitor all these things, but in this specific use case, we are looking at agriculture. So this customer was working in agriculture, and they breed flowers. So not flower bulbs, not real flowers, but stems actually. And they need to know when they are ready to be harvested. They need to know weight of these things. They need to know how en route, how their quality is maybe deteriorating. So all of this is part of possible innovations, and we set up a proof of concept with them, and we did it in Oracle Cloud. So what we were trying to do is to monitor the health, to predict the quality, and also check if we can resolve any issues by incident management. So whenever something is too dark or too wet or too dry or too warm, we should be able to intervene. So as you can see, for the proof of concept, what we did is use a lot of sensors and feed that sensor data to the cloud. And that was only during the time of actual crop growth. So for the proof of concept, we didn't go into the transport, but in general, the solution could be more or less the same by using sensors and sending the data to the cloud. So obviously, think big, start small with proof of concepts and prototyping. So in Netherlands, there's a lot of greenhouses where they grow crop. You can sensor a lot of things like temperature, humidity, light, etc., crop height, and all of that stuff can be sent. Sensors can be sent to the cloud. So what we added to that for the prototyping is just a very simple growth by kit that we took sensors from and implemented those sensors in a small mobile solution that can be used in any agricultural environment to sensor all the stuff that we need to monitor. So not in an entire greenhouse, not with a full-blown solution, but just small plots and small carts. So for the proof of concept, well, let's call it architecture. It's more or less a graphical overview of all the components involved. So we have a small cart that was the monitoring, so size, quality, humidity, temperature. It will send that as a stream to Oracle Cloud, just a simple data stream. And that then again is sent to Oracle Stream Analytics, where it is processed and then filtered and then displayed as information. So from plain data streams all the way to graphical information in a dashboard, and very valuable for the customer to actually have that information available. So let's see how all those individual components that are involved, what do they look like, and how do you set them up, what can you do with them. So first we have a look at Oracle Cloud, so OCI streaming service, which is a, well, it's manageable and durable storage solution for ingesting high volume streams of data that can be consumed and processed in real time. Its use case is where data is actually continuously streamed, and it's sequential in a publish-subscribe messaging model. What you need to do for that is to set up a stream, to set up a stream pool, and then connect to that from wherever you want to send that data. So again, you can do that in the console or by using a REST API, but typically in the console you can just simply create streams. You need a producer to publish data to the stream, and in our case that would be the smart card that contains all the sensors. Then we need consumers that actually read and process the messages from the stream, and then the consumers that we use in this solution is Oracle Stream Analytics. All of the streaming here is compatible with Apache Kafka, so that also means that you can use Kafka APIs to access all the streaming data. So when we said prototyping, this is what we created, a very simple prototype using Raspberry Pi, using Grove Pi sensors, building a simple card with humidity sensors, temperature sensors, light sensors, and also height sensors, which is actually making use of ultrasonic sensors. And that card was more or less autonomous, could drive through the field crop areas and then do all the sensoring. From there, send it to the cloud. Another component, Oracle Stream Analytics, which is well, more or less in-memory technology for real-time analytics, computations, and on streaming data. What you can do with that is, for instance, build operational dashboards that visualize all the processed data streams. Can improve asset management, asset maintenance. You can set all kinds of thresholds. And what we did, we actually translated the asset maintenance and asset management use case into an agricultural use case, where we set thresholds on crop height and thresholds on humidity and thresholds on temperature. Based on those thresholds, we were able to transform all this streaming information into valuable data for the customer. So typically, to set up Stream Analytics can be well, can be quite challenging. However, there is a Golden Gate Stream Analytics package available from the Oracle Marketplace. You can simply launch the stack from the Oracle Marketplace, provide the installer with all the necessary information. Then on your existing OCI account with your key pair, you simply provision the entire stack on OCI, and that's it. It takes some time, but it's much better than manually installing it. So that's how we did it, and from there it's up and running in OCI. You can start the instance from OCI. Obviously, you can stop it, reboot it. It's just a running instance with all software on it installed. So where we did a proof of concept, it was pretty much important to stop the instance every now and then to prevent the customer from being charged with too much usage. So, as I said, we stopped it every now and then started it when we needed it. So, when we have this all up and running, you can actually use the Stream Analytics UI. It's a simple user interface that provides you with all the functionality that you need to build dashboards to do the actual Stream Analytics. There's many examples available that you can use. And for this use case, what we did, we had a look at the IoT samples, but obviously created our own implementation of it. But again, there's a lot of examples available that you can use as for inspiration. So as you can see that from this screenshot, there's for transport logistics, for telecom, retail, etc., etc. But again, we were having the IoT use case, so that is where we used as inspiration. So all these individual components, that's nice, but how do you bring that together in a working solution that actually takes all that information from the sensors, processes the stream, and shows that stuff in an analytics dashboard? So in short, how do we get from A to B? I will tell you, and that's what it is. So for the proof of concept, what we needed was height, temperature, humidity, and light. So as I said, we had that smart small car that is autonomous and drives through the field. And what it does, it reads the height, it reads the light, it reads the temperature and humidity. And for all of that, we use the sensors. So if you look at the code, the first 2 lines of code read actually they use an ultrasonic sensor, and they read the distance, and where we say minimum height that we need for this kind of crop is 5, and then we distract the height that is read by the ultrasonic sensor, and whenever it is resolving to 0, we know that the height of the crop is 5. We have 2, one on each side of the card, to have a more uniform reading. Then obviously the light sensor, it just reads from that sensor and does some calculations. And then there's a simple temperature and humidity sensor. In this example on the bottom, I just printed to the screen, but in the real solution, it will be sent to Oracle Stream. So sensing that data, as I said, to an OCI Stream. For that, I used the Python SDK that is part of Oracle Cloud Infrastructure, OCI, because I am also using Python on the Raspberry Pi to code for all my sensor readings. So install the Python SDK and then create a virtual environment, which is actually best practice for running Python. And from that virtual environment, simply invoke all the necessary code to send that data. we'll get there. So to configure that Python SDK, you will need a configuration file. And a configuration file actually contains all the information that is needed for the code that you write to actually connect to Oracle Cloud Infrastructure. So there's a default configuration already available for you. It's in the .oci/config, and it shows you the ID of the user should be there, the key file that you use. The tenancy identification, the region, and the fingerprint used to decode the key, and that you can actually use it at runtime. So when you have that all in place, you can start using the SDK to code and to send data to OCI Stream. So this is a part of code where I show you how to actually prepare all the stream that is sent to OCI. So first thing that we do is from the top, we define the stream name, we define the compartment, and then we say config equals oci.config from file. And with that command, the SDK understands where to get the config file. It will load the config file and then create all the necessary client-side stream setup to enable you to send the data to OCI. So this is actually everything on this slide, in this piece of code is, so we create the client-side operations, then we will reuse the stream if it's there, and if it's not there, we create a stream. So here you see a compartment ID, and that compartment ID is needed. If you go back one slide, the compartment ID, here you see it in the declaration at the top, is the identification is needed by the SDK to specifically send the data stream to the appropriate compartment. So when you see it, I create an OCI compartment specific for IoT streaming. It has an OC ID, and that one is needed in the configuration. So when we have that, we simply create a string that contains all the information that is needed. So the key that I use for the stream message is actually the identification of my device, and then the value for that message contains all the information that I want to send as a simple string. And then in order to not have too much latency, instead of sending them one by one, I will send 10 at a time. So here you see it again. Publish IoT messages, takes the client, stream ID and a message list, and then simply send them to OCI Stream. And if you look at OCI Stream, you can actually load all the messages that are sent. And if you hover the string of the messages, you can actually see the content of it. So in this case, it contains temperature, humidity, height, and also the coordinates that we need for this proof of concept. So here we have it. We read from the sensors. We create the messages. We send the messages from our smart card, from our Raspberry Pi, to OCI Stream. Now with that, we only have a stream of data, which is nothing yet. We need to transform that into information. And for that, we introduced Stream Analytics. And the thing is that we need to connect from Stream Analytics to the stream. It's pretty much straightforward if you exactly know what you have to do. So here we go. You can create in Stream Analytics a connection that needs a name, and it's a Kafka connection. So we will not use the SAS stuff because it's here. We need to prevent. Sorry, we need to prevent the SSL here because if you check that when doing OCI streaming service, it will not work. So other than that, here we go. Set the username, set the password, and then after that, you should be good to go. And we need a token in it, and that token you can find an authentication token in your user details on OCI. You can generate it, and after you generate it, you copy it. You simply put it here. There we have it. SASL, the username and the password, and then the connection is good to use. You create the stream based on that connection. So that was a very short intro on how to set up the connection between Stream Analytics and Oracle Streams. It's not as complicated as it looks. You just need to copy in the appropriate information from OCI. So once that connection is set up, the next step would be to work with the actual stream. So on Stream Analytics, there's a lot of components that you can use and that you actually need. So first of all, I already talked about the connection and the stream. The next thing would be pipeline to process the data, the visualizations to obviously visualize the data. And then you can bring all these visualizations together on a dashboard that can be used by your end users. So here you see, for instance, a pipeline where information comes in, is filtered, and maybe summarized. So on the top you see the flow in the pipeline, and on the bottom you see live output, which is actually showing temperature, humidity, light, height, etc. So in this specific example, we added a filter to actually not have a look at any data that is not relevant, but only process the data where height is greater than or equals 4. So we will only show specific information when the height of crop meets our requirements. What you can also do in Stream Analytics is create geofences. So for this use case, we created two areas, which resemble crop areas, where that car would drive and do its measurements. And we can actually see live when that car is leaving the specific crop area, and at that time either remotely make the car turn or stop processing data because it's not relevant anymore for that specific area. So here it says it, what we can do with the geofencing. We look at the height at given coordinates. We can plot the info to the map. We can listen to geofencing events, like leaving the area, entering the area, in the area, and more like that. So it's all based, as you can see in the screenshot, on the latitude and the longitude that is sent from the smart car. So let's see if I can show you the demo a bit for real and a bit recorded. I prefer to, well, let's see if we can do it like this. Give me a second here. Yes, here we go. So this is the UI, well, not the UI. This is the command line interface for my Raspberry Pi that contains all the sensors and that drives through the field. It's currently not driving for real, but I have it set up at my desk. And if I start the interface here, it will start processing data, reading data, sensor data, collect it, and then it will print out to this screen, but it will also send it to OCI streams. And once this is starting, should be any minute now, I can go here and show you that it is actually coming in. So in here, I can go to analytics and then streaming. Okay, let me just see if I can. Okay. So on the right-hand side, you see all the data being processed. And typically, what we need now is here on the left-hand side, we go to analytics. Where do we have it? We got a bit distracted. Here's analytics, streaming. Here's my sensor stream pool and my sensor stream. And if I click on the stream, on the bottom here, we should see all these messages coming. There you go. There you go. So these are all more or less live messages. As you can see here. And this is all running. And I should also be able to see the dashboard here. Yeah, that's what I was afraid of. It needs me to go to the login page first. I don't know the password by heart, but that should be fine because I have it here. Okay. So from the log file, from the screen that is refreshing here with all the data, sensor values for humidity, latitude, longitude, you see all every now and then it sends 10 messages to prevent a lot of unnecessary network traffic. I choose to send 10 at a time. You can also choose to send 100 or whatever makes sense to you. So what I can see from my Golden Gate Stream Analytics is that it takes quite a while to refresh. So what I will do for now is I just hit this one and then show you a recorded version of it, because that makes more sense. So here it is. And let's just start here and see if that makes sense. Okay, so I already told you about this one. Stream Analytics, processing data, filtering data, and displaying it on a dashboard. And with that, this is the smart car as we used it. Really worked well. So these are the sensors that measure the height. So it's ultrasonic. On the front, there's a sensor to prevent the car from colliding. So at a given distance to an object, it stops the turns. Here is the light sensor. There's the temperature humidity sensor, all connected to a GoFi board on top of a Raspberry Pi. And obviously, this is the controller for all the motors. Again, these are the components involved. Stream Analytics, that shows you all the incoming data. Then the stream on OCI that, as I just showed you, displays or loads, receives all the information and shows it. Well, this is the code as we use it for this specific demo. Coded in Python, very straightforward. And here there is the command that I just also demoed, showing all the information. For the specific part, I'll just go ahead a little bit. This is for fun. Okay. So this is where the car runs. As you can see, it actually works, measures the height. This was a test of the prototype, obviously. Gathering all information, sending it in batches of 10 to Oracle Streams. And then I'm just going to speed up a little bit, because this is where all the sensor data comes in. I already displayed it to you. And obviously, there is a connection between Stream Analytics and this Oracle Stream. And let's go forward to Stream Analytics now. Here we have it. So here's the pipeline, and as you can see on the bottom, there is data coming in, live data coming in. Temperature, humidity, light, height, longitude, latitude, everything is there. And in this pipeline, everything is just filtered and displayed. So here is the dashboard that shows everything. And on that dashboard, and it will take a few seconds, but here you see some arrows, and these are arrows displaying the crop height at that given location. So the red ones display a crop that is too low. The yellow ones will display crop that is about the correct height, and the green ones display crop that is ready to be harvested, as you can see here. So these are measurements for specific areas. And obviously it's prototyping, it's proof of concept, but for the customer, this proves that with all the data that is available but was never used, they can actually work with it, and from there derive all the information they need. So let's stop this one, continue with the presentation, because what we did here, there's one thing that I didn't show. So here on the right-hand side, you see blockchain. So what we plan to do in the near future is to publish also relevant information to blockchain, especially in the supply chain. So customers can also always track and trace the batch that was harvested for their use. So to summarize it, I mean, we started a bit late, so I should have a couple of minutes left. Internet of Living Things is very powerful to share information about quality, but also to check quality, to check crop height, to check environments. And you don't really write directly to your back office or other systems. You just handle the data, process the data, and from there work with it. Then you can also use artificial intelligence and machine learning algorithms. That is something that we are looking at for the near future also, to combine crop height with also phenotypical characteristics. So looking at the thickness of bulbs and flower buds to see whether or not it's ready to be harvested. That's something that we are looking into with image recognition and stuff like that. So I already showed you this one for the blockchain. And then to summarize, think big, start small. I mean, the customer came up with an open question. How can you help us to improve our quality with IoT, or actually our production process with IoT, which is big. We took that challenge and then created our own boundaries to just look at some very specific information, starting really small as a prototype. And we're about to enter a proof of concept phase now. So that's why we did the prototyping. It helps to find the best solution. So for very large areas, it's not really practical to use this card. Not near future, but midterm, we are looking with them at drones. We will enter an IoT inspiration workshop with them to see if drones can add value for them. So for the cloud, it's really highly scalable. You can send as many messages as you want. It can be handled and analyzed in just a fraction of time. You hardly see that message is processed. It's just displayed immediately on the dashboard at the correct place with the correct colors and everything. So again, proof of concept, and it was only the start of something that can and probably will become very big in the near future. So with that, it is time for questions. So if you have any, please let me know.
Yes, if there are any questions, you can actually type your questions in the Q&A and also in the chat.
Okay, so no questions?
Yes, there's no question. Yeah.
No questions.
Okay. Yeah, no questions, I guess.
Okay.
That was an interesting proof of concept, actually. And yeah, it's exciting to know that to hopefully in the near future we'll be able to see more products like this.
Yeah, it's fun. It's fun. So yeah.
Okay, thank you for sharing that.
You're very welcome.
To the community. And yes, your session is going to be up in Groundbreaker site for the next 2 weeks. Yep.
Okay.
Okay, cool.
Thank you.
Thank you, and
Okay.
have a good day.
Same to you. Bye-bye.
Bye.